So, good morning, everyone, and this is a brand new day, a brand new week, and a brand new topic. Not a brand new topic, we are already there in motion in one dimension. We had seen the types of motion: translational or rectilinear, curvilinear, motion in 1D, motion in 2D. And the last thing that we did in the last class was to understand the meaning of rest and motion. Yes or no? Do we remember this? So what do you mean by rest and what do you mean by motion? Well, it all depends on one most important thing. And what is that most important thing that rest and motion depends on? What?
Frame.
It depends on reference frame. Depending on your reference frame from where you are watching it, rest and motion can be completely different, and therefore we use this term, and I hope you will write it: rest and motion, and you will write it: rest and motion are relative terms. This is how we emphasize that they depend on reference frame. So to specify that they depend on reference frame, we call them relative terms. Relative term does not mean that they are related to each other. Relative term here means that they depend on relation with the reference frame. If you change the reference frame, things may start to look different. So far so good, yes or no? Then comes the next point, and that is distance and displacement. So the first of these is the well-known commodity, which is distance. Distance traveled by a body, and we will do it fast because I know that all of you know what distance traveled is. So now tell me, what do you mean by distance traveled? When you say distance traveled by a body, what do you mean by that? Yes. Remember, there are no right answers and no wrong answers. Don't worry about right and wrong in your life. You're too young to understand what is right and what is wrong. Yes, tell me. What do you understand by distance? Distance traveled by body.
Length of the actual path covered by a body in given time.
Great. This is the best definition that I have heard for in a while. Well done. How did you get this definition? Did you know it before, or you learned it just 1 or 2 days back? Tell me.
We learned before only, sir.
Well done. That is the correct definition of distance traveled. It is the, what's wrong here? Why it is moving? It is the length of the actual path followed by the body. So it is the length of the actual path followed by the body. When a body moves from one point to other point, it may follow a path. It may follow a path. The length of that path is known as distance traveled. Do we understand this? Length of the path followed by the body is known as distance traveled. So let me show you with an example. Now remember, the name of the topic that we are doing is motion in one dimension, but the definitions that we are doing, and as you will see, that these definitions do not depend on dimension. When I say they do not depend on dimension, what it means is whatever definition we are doing for distance, displacement, speed, velocity, they do not change if the motion changes from 1D to 2D and 3D. Definitions are always same. Do we understand this? Definitions don't change, my dear friend. I don't say that, beta, this definition of distance is only valid for one dimension. No, it's a definition. It is always valid. So let us take an example of a body Let us say moving from point A here. To understand this position, we must have a reference frame. So you can see our reference frame. You can see the reference frame, yes or no? You have a reference frame and you have an origin so that you can understand where the position of point A is. Then you have point B. Now the body has moved from point A to point B. It may follow many paths. For example, it can follow a path which is a straight line going from A to B. It can follow a path like this, the pink or the whatever color this is, can't recognize color. You can follow path like this. But more often or not, you will see if you are going from one place to another, you don't always move in a straight line because it's not possible to move in a straight line. You're not going to move in a straight line. Probably you are going to follow some path which may be of any particular nature. It may be like this, the green one. It may be like this, the red one. It can follow different paths. The length of this path, whether it's the green one, the purple, whatever color that is, and the red one, the length of this path, if I just write the length, I find out the length of this path, the length of this total path, the length of this total path is known as distance traveled. Do we understand this? Since I call it the length, no, I don't call it the length. Since the definition calls it the length of the path, therefore I will always refer to distance as L. So wherever I use the letter L, it basically refers to the distance, because that will remind me that I'm talking about length of the path. So it's the length of the actual path followed by the body. So it is the length of the path. What is the SI unit of distance? So we will write them as important point. What is the SI unit of distance? Tell me fatafat.
Meter.
The SI unit is meter. Well done. What type of quantity is this?
Scalar quantity.
Scalar quantity. Okay, so far so good. Now if it is a scalar quantity, it can be added. It can be added or subtracted just like numbers. Yes or no?
Yes, sir.
For example, if I go from A to B, let us say in the green path, and I travel a distance of 5 meters from A to B, then I come back from B to A, and let us say I travel a distance of 4 meters when I come back in the path, red path. What is the total distance traveled by me from A to B and from B to A back? I go from A to B. I travel a distance of 5 meters, which is the length of that green path. I come back from B to A, 4 meters, the length of the red path. What is the total distance traveled by me?
9.
It's 9 meters. You just add it. Yes or no? No or yes? So
Yes, sir.
they can be added or subtracted just like numbers. Now, when we are talking about distance, we are talking about length of the path. Now, when I go from A to B, the length of the path is 5 meters. When I come from B to A, does the length of the path become minus 4 meters? Or it still remains 4 meters? When I go from A to B, the length of the path is 5 meters. When I come from B to A, different path, the length of the path, is it minus 4 meter or is it still 4 meters?
-4.
Minus 4. Therefore, the total distance will be 1 meter, right? Because 5 meter minus 4 meter is 1 meter. But you said 9 meters. So when I come from B to A, the length becomes minus 4 meter. Is that so? Yes. Anyone? Say, how many of you think that it is minus 4 when I go from B to A? Please raise your hands. If it is not minus, then it has to be plus. So why are not people saying it? Yes. See? I'm waiting. How long should I wait? No one has the answer? From A to B, the distance traveled is 5 meters. When I go from B to A, is the distance traveled minus 4 meters? That is my question. Or is it plus 4 meters? There are only two options. I'll wait unless I get an answer.
Plus 4, sir.
Plus 4. Why it is plus 4?
Distance never be negative.
Distance can never be make it negative. Why it can be never negative? Because it is the length of the path. When you talk about length, the length of this pen, let us say, is 10 centimeters. You look it from whatever angle, however you measure it, you will never get negative. Therefore, distance is always treated, or distance is always positive. Distance is always positive. You cannot travel a negative distance ever in your life. You will always travel one positive thing in your life, and that positive thing in your life, my dear friends, is the distance. Whatever distance you have traveled in your life up till now, and whatever distance you are going to travel in your future life, they're all going to be positive always. Do we understand this? Distance can never be negative because it is the length of the path. Length of the path can never be negative. Now let us talk about one more thing. If I go from A to B in the purple path, the straight one, I don't know which color is that. What color is this? That straight one? Purple? Which one? This color. This color. What is this color? Purple. Pink. No, it's not pink. What do you call this color? No one knows it? Oh, that means I'm not the only one who has a problem in recognizing color. There are a lot of people like me. Okay, whatever color is this? The straight line path. You go from A to B in the straight line path, or you go from A to B in the green path, or you go from A to B in the red path. Are all distances traveled? Are they same? Can they be same? Distance traveled depends on path, and therefore for different paths it would be different. So we'll have to understand this, that distance travel depends on the path. If I follow one path, the distance travel may be different. If I use a different path, different road, different way, the distance would be different. People tend to use shortcuts, and whenever we are using shortcuts, we are bound to face problem. It is always better to take long cuts. So it depends on path. Now, since it depends on path, to calculate distance, and that's a very important thing, to calculate distance, we need to know the path. To calculate distance, we need to know the path, and the path may be very zigzag, and therefore to calculate distance may be a very tedious job. Whenever someone asks you in any paper, in any question, to calculate the distance traveled by the body, be aware because it might be a tricky question, because he may follow a zigzag path like the one in green or the one in red. He may not go in a straight line. Even if he goes in a straight line, he may take a turn back, and then the distance traveled, we'll have to watch very carefully how he has traveled that distance, which path he has followed, from where to where he has gone, how he has gone, and therefore the most difficult question will be for the distance traveled unless and until someone tells us the path. Do we understand this? Yes or no? Well done. I hope you have noted this down. This was all about distance traveled by the body. What is the next thing, next term that will come? Next term. Yes, my dear friends.
Displacement.
Displacement. Yes. That is the next term that is going to come, and that is displacement. Now, tell me, since you have told me a very nice definition of distance, tell me the definition of displacement in the same tone. What do you mean by displacement? Remember, definitions are to be understood very correctly, because if we understand the definition wrongly, then we have started things on a very different note. And if the definitions are wrong, then we might land up in trouble. Yes, what do you mean by displacement? Displacement. What do I mean by that? Yes. Again, I must have an x-axis, I must have a y-axis, and I must have a particle. I must have an origin from where I am going to calculate everything. The particle is supposed to go from point A to, let us say, point B. And he may have followed this path, the green path, the upar wala path, like this. He would have gone like this in a zigzag path. If I calculate the length of this path, what will it give me? The length of this path will give me what? The length of this path will give me what? The length of the green path will give me what? If I calculate the length of this path, the green path, what will it give me? Yes? No one knows it? If I calculate the length of this path, the green path, what will it give me? I'm waiting. I hope I'm audible and visible to everyone. What will the length of this path, the green path, when I go from A to B, what will it give me? I'm waiting. No one has an answer. I'll give you 5 minutes. Find out the answer and tell me what will the length of this path, the path AB, give me. Is the question clear to everyone? I don't see the other class. I have no idea whether they are in the class or not. Yes. I'm waiting. No one knows what does the length of the path give us?
Sir,
Yes.
distance.
Why does it take so long for you to answer, beta? Is it not? You don't understand it? Is that so? Shall I repeat? What is distance? Shall I repeat it? If it takes 5 minutes for you to answer this question, just after I have done this, so I would request some of you to read what is there on the whiteboard right now. Can anyone read this? All these points? Can anyone in the class, any of the classes, read all the points that are there that I've written? You have written probably. Yes? Can anyone read the points? Is it so difficult to read?
Length of the actual path.
What is length of the actual part, beta?
Distance.
Okay, very good. Please read the second point.
SI unit meters.
Okay, well done. Third point.
It is a scalar quantity
What do you mean by scalar?
which doesn't have any direction.
Okay, fourth point.
Added or subtracted like numbers.
So we can add distance or subtract distance like numbers. Well done. Next point.
Distance is always positive.
Because length is always positive. Okay.
Distance depends on the path.
Different paths, different lengths, different distances. Okay.
To calculate distance, we need to know path.
Well done. Congratulations. Thank you. Okay. So now let us now come back to what the question I was asking. I go from A to B and I followed this green path. What does the length of this path give me? Come back to the same question. What does the length of this path give me?
Distance.
Yes, thank you. Well done. It gives me the distance. Be fast in response so that I understand better that you understand it. Else, if I go in haste, I may follow my own speed, and if you don't understand it, that will be useless. And I don't want to do something which is useless. Okay, so length of this path is the distance traveled. Heading is displacement. What do you understand by displacement? How will I find the displacement? Anyone can tell me? What kind of quantity is a displacement? Let us go on that point. What kind of quantity is displacement? It is a
Vector.
It is a vector quantity. Okay. It is a vector quantity. What is the SI unit of displacement? SI unit of displacement?
Shortest distance between initial point and.
What is the SI unit of displacement? Let us first get that one. SI unit is meter. Okay. So far, so good. Okay. Now, it is a vector quantity. Okay. If it is a vector, okay. Now, someone was telling me something. Yes, beta, tell me. What were you saying? You're saying something, na? Shortest something. What? Say? The SI unit is meter. You understand it?
The shortest distance between initial point and final point.
The shortest distance between initial and final point, that is
Sir,
displacement, right? Now, let me ask the question again. What type of quantity is displacement, bacha? What type of quantity is displacement, beta?
vector.
Vector. And what did you just tell me? It is the shortest distance. What type of quantity is distance? What type of quantity is distance?
Scalar.
Okay. Now, displacement is a vector quantity and distance is a scalar quantity. So you are trying to make me understand displacement with distance. Now, if I give you an example, for example, there is a very small boy. He likes apples a lot. He loves apples. He understands apple. One day he sees a tomato and he comes to me and he says, Papa, what is this? Now I understand that this is a tomato, but he likes apple. For me, I think that it is difficult to tell him, beta, this is a tomato, this is a vegetable, we put it and we make wonderful dishes. This is not a fruit. Fruits are different, vegetables are different. But I say, why giving so much? Okay, tomato, beta, this is an apple. Apple is also of the same shape. Tomato is also of the same shape. It also looks red. This also looks red. It may taste different, so what? Tomato is apple. Apple may be a fruit. This is vegetable. No, it looks same. Tomato is apple. Tomato may taste differently. So what? Tomato is apple. I cannot make vegetables out of tomato, out of apple. So what? Tomato is apple. Is that a correct description of tomato? Tomato is apple? Or it looks like apple? Is it the correct description of tomato? Am I doing justice to tomato? Am I doing justice to apple? Or am I doing justice to none of these? Yes. Simple question. Tell me. Tomato is apple. Apple, tomato, look same. So what? They are vegetables or fruit. Who worries about them? Who worries about the taste? Let me make him understand. Because they look same. Yes. Can tomato be equal to apple? Yes or no? Can tomato be equal to apple? Yes or no? I'm waiting. Do we understand what example I have given? I have tried to explain tomato using an apple. Is this the correct thing that I have done? This is a yes, this is a no. I'll wait until I get an answer. Don't worry. I have left lots of time. So if you want to keep sitting quiet, I'll sit quiet as well. Not a problem. I'm waiting for an answer still. Tomato and apple, are they equal? No one in class?
No, sir.
No, sir. Okay. Why it takes so long for you to answer? No, sir. That means there is something fundamentally wrong. I cannot explain a tomato with an apple. And that is the same difference between displacement and distance. That is why I have taken so long for you to understand this. Now, if you are trying to understand displacement with distance, whenever you think about displacement, you will think about distance. And remember, they are totally different things. They are even more different than an apple and a tomato, because apple and tomato you can both eat. Distance and displacement are really different. One is a scalar, the other one is a vector. Now, if other one is a vector, it cannot be explained by a scalar, because vector quantities are entirely different than scalar quantities. Do we understand this? It's like explaining force using mass. Force is vector and mass is scalar. But you say, sir, F is equal to ma, so I can explain force with mass. No. Since F is equal to ma does not mean that I can explain force with mass, because they are entirely different quantities. Distance and displacements are entirely different quantities. Remember, displacement is a vector quantity, so you have to understand it in terms of vectors, not in terms of scalar. Whenever you have heard shortest distance, someone has fooled you, or someone has tried to make you understand just to make it simple, just to make something simple. We have messed up the entire concept of what that thing was. We cannot understand something just to make it simple. We cannot just underestimate or take away what it was. Displacement is a vector quantity. Now, let us go back to this. This point A is known as the initial position. We all know this. This point A is known as the initial position. Yes or no? This point B is the final position. We all know this. Yes or no?
Sir.
That is how displacement is defined. It's a vector quantity. So what you do is you draw a vector joining what? Oops. I have not joined it correctly, so I'll again try. It's a vector which is joining your initial point to the final point. That is known as your displacement vector. In this case, this displacement vector is your AB vector. So the simplest way of writing this vector is, it is a vector joining. It is a vector joining what? Initial to final point, that is known as displacement. And this is how you must always remember it. It is a vector joining initial point to the final point. Do we understand this? Do we understand this? There is no shortest distance coming. There is no shortest distance coming ever. Because if you understand it in terms of shortest distance, we'll always think it of as a distance. It is not distance. It is a vector which joins the initial point and the final point. That is known as your displacement vector. We understand this? Now this displacement vector, this displacement vector, I will always write like this. Delta R. This delta stands for change, and this entire thing stands for position vector. Position vector. Now what do I mean by position vector? In short, the body, at first it is at point A, so I joined O to A. That becomes my OA vector. My OA vector is the initial position vector. Then I join O to B. My OB vector is the final position vector. So I can also write the displacement vector is final position vector minus initial position vector. Is it clear to everyone?
Yes, sir.
So I can write it as OB vector, which is the final position vector, minus OA vector. This is my displacement vector, and this is the best and the simplest way to understand and to define displacement vector. We should not think in terms of shortest distance, because that is going to give us a lot of trouble. Do we understand this? Now you can understand that the definitions are completely different, and therefore distance and displacement are not related to each other in any ways. Distance and displacement are not related to each other in any ways. Do we understand this? Now, Just to come to your point, sir, we have always read displacement as shortest distance, displacement as shortest distance. Sir, please not confuse us. So just for your understanding, or just for you to understand that we are doing the same thing but we are now doing it correctly, displacement is a vector quantity. Now every vector quantity will have two things. Every vector quantity will have two things. What are those two things, bacha? Every vector has two components, two things.
Magnitude, direction.
Well done. Now we are talking. It has magnitude as well as it has a direction. Now, if you want to understand displacement in terms of these two quantities, then you can use your definition that you were saying. What you were saying? The magnitude, when you said it is the shortest distance, beta, you were probably referring to its magnitude. When I talk about the magnitude of the displacement vector, beta, please see this green. Oh, green may not be a good color here. This pink line, this pink line is the length of this vector. Do we understand this? This pink line is the magnitude of this vector, and this pink line is the, you can also call it the shortest distance. So if you say shortest distance, if you say shortest distance, it refers to what, beta? When you ever say from now onwards, whenever you refer to the shortest distance, remember you are not referring to the displacement, you are only referring to what? You're only referring to what? When you say displacement as shortest distance, which thing are you telling me?
Magnitude.
What, beta?
Magnitude.
Well done. You are talking about the magnitude. But only telling magnitude will not make much sense. So you must also talk about direction. How do I get the direction? The direction is from initial position IP to FP. What does IP stand for? IP stands for initial position. FP stands for final position. Do we understand this? Yes or no?
Yes, sir.
Okay. These are the things that you must remember about displacement. Displacement is a vector joining initial to final point. You can also call it is the change in position vector. You can also call displacement as change in PV. What do I mean by PV here? Fatafat, tell me. We are now picking up some speed. What do you mean by PV?
Position vector.
Well done. Position vector. PV stands for position vector. Well done. Now, tell me, A to B, I go in green path. Distance is different. I go in black path. Distance is different. I go in some other path. Distance would be different. What about displacement? I go from A to B in different paths. What can you say about displacement? Does it depend on path or does it not depend on path? Fast, give me the answer. I go from A to B. I've drawn two paths here. One is the green path, the other one is the black path.
Depends on path.
What depends on path? Distance or displacement?
Displacement.
Displacement depends on path. How many of you agree on this? Please raise your hands. We don't agree? That means it does not depend on path. Whatever the answer is, there must be a reason behind it. Why do we think that distance depends on path? Why do we think that why do we think displacement depends on path? Why do we think displacement does not depend on path? And it is very clear from the definition. Can anyone explain whether it depends on path or not? Fatafat, jaldi, we don't have time. Anyone would like to say? Displacement does not depend on path. You go from any path, the vector will be drawn from initial to final position, and that vector will always remain same. It only depends on initial and final position. If I keep initial and final position same, then displacement would be same in all cases. Distance may be different in different cases. Do we understand this? Yes or no? Can I have raise hands from everyone in the class? And I hope everyone is noting this down. Yes or no? Okay, I'll give you 2 minutes to write it down. If anyone has any doubts, please ask me. I'm taking a lot of pain and a lot of time in explaining these things. I hope that time and that pain is worth it. I could have very really gone without so much of explanation. Have you noted it down? Shall I move ahead? Now we'll just write down the different comparisons between distance and displacement so that we understand them more correctly. Comparison between distance and displacement. And here is the first thing that you might have heard in your lower standards. The magnitude of displacement. Remember, I'm using always the term the magnitude. The magnitude of displacement is equal to the minimum possible or the shortest distance or the straight line distance. You can write anything. You can write minimum distance, shortest distance, straight line distance between two positions. Therefore, distance will always be greater than the magnitude of displacement. Do we understand this? Yes or no? Everyone is raising hands. Yes or no? Yes. Well done. That is the first point. If anyone has a doubt, please tell me. Otherwise, we will keep on noting this point and moving ahead in life, because in life we will have to move ahead. That is point number 1, my dear friends. The magnitude of displacement. The magnitude of displacement, not displacement. The magnitude of displacement is the shortest or the minimum distance, straight line distance, and it is always less than or equal to the distance traveled. In which case, both of them are equal. The magnitude of displacement and the distance. In which case are they equal? Can anyone tell me? In which case are they equal? In which case are the magnitude of displacement and distance traveled equal? Yes, waiting for your answer. In which case the magnitude of displacement and distance are same? Please tell me, beta. Anyone? In which case is the magnitude of displacement equal to the distance traveled? Yes, beta, tell me. No one knows it? No one knows it? This is a yes? Sir, I don't know. No one knows it? When is the displacement and magnitude? We don't know. Okay, then you will find it out. In which case displacement, magnitude and distance traveled are equal. You can find it out. So I'll ask you in the next class. Okay, can you do this? Okay, then that takes us to the second point. And we might have heard this point. For a moving particle, distance can never be negative or zero. Did we discuss this or not? We discussed this, but displacement can be. Now we have to understand what we mean by this. Zero displacement. Have you heard about the term zero displacement? Displacement can be zero. When can displacement be zero? Anyone tell me? When can displacement be zero? Tell me fast. When can displacement be zero? If the particle comes back to its initial position, the displacement is zero. I start from point A, I go to point B, I could have traveled in this way. I will have some distance traveled. Well, I could come back in this way. So I've gone from A to B in one path. I've come back from B to A in the other path, other way. The distance traveled is not zero, but the displacement is zero because I come back to the same initial position. Do we understand this? Okay. Now, that is about zero displacement. Note this down. Now, sometimes we hear the term positive displacement and sometimes we hear the term negative displacement. Remember, positive and negative only depends on direction of motion. So when someone talks to you about positive displacement, when someone says negative displacement, they're only talking about the direction of displacement. For example, if something is moving along positive x-axis, something is moving along positive x-axis, something is moving along positive x-axis, we can call it positive displacement. Then something moving along negative x-axis will be known as what? If positive x-axis wala vector is taken as positive, negative x wala vector will become negative. Do we understand this? So whenever we talk about positive and negative displacement, positive or negative velocity, positive or negative acceleration, we are talking about the direction. Do we understand this? Similarly, beta. Oops, what has happened here? Just a minute, something has happened. I will check what has happened here. Where I have gone. Oh, okay. I have gone here. Why here? Okay, let me again share the screen. Okay. So whenever I am talking about positive or negative displacement, I am talking about directions. Okay. Say for example, if I am moving along positive y-axis, I can call that displacement or velocity as positive. Then, bacha, when I move along negative y-axis, I'm not able to draw a straight line. When I move along negative y-axis, I will call it as negative, and that is the convention that we are going to use always. Something moving along positive x will be positive, something along negative x would be negative. Positive and negative only refer to its direction. Do we understand this? Yes or no? Okay, this is the second point. We are comparing distance and displacements so that there is no confusion left between distance and displacement. So far, so good. Yes or no? Then comes the third point. We'll try to memorize and put all the points together so that there is no confusion between the points. Here comes the next point. Distance between 2 points depends on path. We have seen that distance depends on path, but displacement does not depend on path because it is a vector which joins the initial and the final position. Do we understand this? That is our point number 3. Do we understand this? Raise hands will give me more confidence that we understand this. Distance depends on path, but displacement does not depend on path. Point number 4. Distance is a scalar quantity and therefore it can be added like numbers. Can you add displacement like numbers? Can you treat displacement as number? Tell me, can you treat displacement as number, bacha? This is a yes, this is a no. Can you treat displacement as a number? Can you treat displacement as a number? Yes, no, yes, no. I mean, no, we cannot treat displacement as a number because this is a vector quantity. It is added using vector laws. Have you gone through the vector laws? This is a yes, this is a no. You've gone through vector laws? Yes, it is added using vector laws of addition, triangle law, Falana law, Dimaka law. That is what we use to add vectors. Okay, 2 more points and we'll call it a day. And those 2 points are coming together now. And I asked you a question. And here comes those 2 points. Point number 5 and point number 6. Point number 5 is very simple. And it says that in general, the magnitude of displacement is not equal to distance. Magnitude of displacement is not equal to distance. Magnitude of displacement is always less than or equal to distance. However, if the motion is along a straight line without changing direction, if I am moving in a straight line and I never change my direction, then both these quantities are going to be same. That was the question that I asked. Do we remember this? That was the question I asked. When are magnitude of displacement and distance same? So the answer is, sir, they are same when the particle is moving in a straight line. Do we understand this? And the last point is the definition of displacement and distance. I go from A to B. My A is my initial position, IP. My B is my final position, FP. I can go in different paths. If you look at here, S, or I will call it as L. L is the length of this path, and the length of this path is known as distance. Whereas if I subtract final position vector, this is the final position vector, subtract initial position vector from the final position vector, that will give me the displacement. Do we understand this? Displacement is final position vector minus initial position vector, whereas distance is the length of the path. We have finished this class on the same note on which we started it, the definitions of distance and displacement. In the next class, we will be doing some problems on distance and displacement, and I hope that with those problems you would be able to understand more clearly what we are talking about here, what is distance and what is displacement. Is it clear to everyone? Can I have some raise hands that we have understood this? Distance and displacement. One is a scalar, the other one is a vector. One is the length of the path, the other one is a vector drawn from initial to the final position. I hope everyone has noted this down. I'll keep on sharing it. Meanwhile, I will say goodbye and I'll see you in the next class. That will be on the next day. Remember, before coming to the next class, please go through what we have done in this class. Can you do that for me? Because if you come back not studying anything, then it will be difficult for you to understand what is going to happen in the next class, because in the next class we'll be going on and solving 2 or 3 very good questions which have come in your exam based on distance and displacement, and we will move on with the other quantities as well. So I'll see you in the next class. Take care. Have a nice day.